This weak question is not a numerical problem. The question reads, following a magnitude 6.8 earthquake, an inspector documents the following at a single-story commercial building site located about 50 feet from a meandering stream channel. Ground cracks running through roughly parallel to the stream and visible across a 200 feet length of parking lot. Ejected sandstones on the surface, 1 to 4 feet in diameter, and the building has tilted 1.5 degrees toward the stream with about 4 inch of differential foundation movement over its 60 feet length. Pre-construction SPT log shows N160 of 7 to 10 in saturated fine sand from 4 to 6 meters below grade, with the water table at 2 meters, which best diagnoses the observed damage. So this question is relatively easy because it has 3 signs of a typical liquefaction situation. One of them is the sand boil. When you have liquefaction, when you have liquefaction, you typically see sand boils on the surface if the situation is appropriate. Also, having cracks parallel to the stream is another sign of liquefaction, and also having differential settlements. So all 3 signs point to the option B. So this is our correct option. Option A reads a static post-earthquake settlement of dry sand from cyclic densification causes differential movement. If it was dry sand, we wouldn't see the sand boil. Sand boil is because when liquefaction happens, the pore pressure goes through the dense layer. So if you have a soft layer from 4 to 6 meters, this layer liquefies and it creates sand boil in the dense layer and shows up on the ground. So the fact that we have sand boil, it means option A is not correct. Option D says the surface fault rupture along the stream alignment with the cracks and tilt representation direct fault offset. So fault, if it was fault, we would see also the cracks, but the crack wouldn't be parallel to the stream. The fact that it is parallel to the stream and we also have sand boil, it means that option D is also incorrect. And bearing capacity failure from earthquake-induced inertial loading is also not correct, again, because we have sign of liquefaction. And we wouldn't see this much settlement just because of bearing failure during an earthquake. So the option B is the correct option. Any question for this example, or if you have general question about when you saw the course, any question came up you need help with?
Is this a typical style conceptual question on the exam?
Yes.
Okay. So they're going to give you a lot of potentials and you have to meander through what the exact probability will be. Okay.
Yeah, and it's more about understanding when seepage happens, where liquefaction happens, where bearing failure happens. So being familiar with different damages in geotechnical engineering is helpful during the exam.
Okay. Thank you.
Sure. Okay. Thank you for joining. If you have any question, let us know. We can go over it during the next week. And good luck studying. Have a good week. Bye.
Thank you.